Hello everyone. Everything is fine or not? Check. Yes, fine. Hello everyone. Myself Divyanshu Srivastava and today I am going to teach you. My voice is clear or not? I am audible. I think some voice issue. If yes. So everything is fine or not? Yes. Yeah, everything is fine. So today is the class which will be I will teach you some related to elementary differential equation. I think this is a beginning of class. I'm starting. I think uh, I cover more than 11 lecture to complete this, or I think maybe 4 to 5 lecture for complete this. This is unit first. The reference book is MD Rai Singhania. Okay. So today my aim is to just discuss you what is the differential equation and how many terms you have to learn. Okay. So now the first things is differential equation, then move on equation of first order and first degree, and third part is trajectories, and fourth part is equation of first order but not of the first degree. It is singular solution or extraneous loci. Okay. And fifth part is linear differential equation with have some constant coefficient. And sixth topic is homogeneous linear equation or Cauchy-Euler formula. Cauchy-Euler formula is very important. Now in method 7, the learn about method of derivation of parameter. In 8 part, we have some touch about the ordinary differential equation like this. So ordinary simultaneous. In 9 discuss chapter, I will move on ODE and PDE portion. Okay, ODE and P portion after complete and their first order and first degree type and what is okay. So first things, what is differential equation? My question is to you. Say me, what is differential equation? Is every person is life? First things, every person, one person, if able to tell what is differential equation, then I will move on my next topic. Okay. Okay. So no one can reply this. So I will move on the topic. The main content for today is differential equation and their formation and solution. Now come to the differential equation part. Differential equation is nothing but what is differential equation? Okay. Yeah. Any person can reply this. Me. What is differential equation? So I will tell you an equation involving some derivative or differential of one or more dependent variable with respect to one or more independent variable. Okay, this is called a differential equation. What it means, the important terms is here is dependent variable and one or more independent variable. What is dependent and independent type the case? So first you things you have to know about what is dependent and what is independent variable. Okay, so in basic class you have already learned about the rate of change of velocity or rate of change of anything. Okay, so their concepts are used apply here by taking some more and more behalf of I think formation of ODE and formation of any curves or formation of anywhere. So must we know what it means? It means that the dependent variable is nothing but an dependent and independent variable like this. Take here y is equal to fx. Okay, and y is our dependent, y is our dependent, and x is our independent variable. Okay, so the differential equation is what? An equation involving derivative or differential of one or more dependent variable with respect to one or more independent variable, which is called as differential equation. There are few examples are given here. First one is dy equal to x plus sin x dx. Second equation is d to the power 4x upon dt to the power 4. It's look like some parametric type. Okay, so d2x upon dtx square plus dx upon dt to the power 5, which is equal to e to the power t. Now the third one is y is equal to under root x dy upon dx plus k upon dy upon dx. And move on four part, that is k d2y upon dx square equal to 1 plus dy upon dx to the square, and move on power 3 by 2. Okay, and next equation is given in like partial type. So del 2b upon del t square, which is equal to k del qb upon del x to the power q 2. Okay, and these are the formation of, and these are the example of differential equation. Unless otherwise, y dash or y1, say that y dash or y1. And now when you differentiate this term in second times, then you say that it is form of y double dash or y2 and up to yn. Okay, so first one is y1 is denoted like this, dy upon dx, which is equal to y dash. Okay, so now I am right here y dash, which is equal to dy upon dx. Okay, y double derivative look like this, d2y upon dx square. Understand? And y triple derivative, it's look like dy q upon dx q. Further, we have some n type of terms. Then say that the differential equation is d to the power n y upon dx to the power n. Okay. So for example, the equation 3 may be written as, where is equation 3? Here is equation 3. Okay. So in case of y double derivative and y dash, what you have to write and their representation say and look like this. Okay, because you put here dy upon dx, which is y dash, and here dy upon dx is also a y dash. So we write here y is equal to under root x y dash. Okay, plus k times upon denominator y dash. So these are the representation of only differential equation. Okay. So next one, what the concept comes in your mind. So next one, I will show you the ordinary differential equation and move on partial differential equation and further the concept of order and degree part. So I am say you equation. So ordinary difference. So ordinary is that a differential equation involving derivative with respect to single independent variable, which is called as ordinary differential. Now, in before lecture, I am show you something equation. Okay, so equation number first, 2 and 3 and 4. Okay, their definitions say you a differential equation involving derivatives with respect to a single independent variable and are called as ordinary differential equation. Definition of ordinary differential equation. Here, equation of derivative type. Okay, there is nothing but here is the derivative is only dy upon dx, which is equal to x plus sin x looks like first you. When you arrange this, d upon dx, which is equal to what? X plus sin x. Okay. Now move on. The second part, the a differential equation involving derivative with respect to a single independent variable. Single independent variable. So independent variables look like this, na? Y is equal to fx and the x part is independent variable and x part is dependent. So in this case, 1, 2, and 3 and 4 all are ordinary differential equation. Now move on to the next part, which is partial differential equation. A partial differential equation, what it means? It means that involving a partial derivative with respect to more than one independent variable, which is called as partial differential equation. Understand? A partial differential equation is nothing but a partial differential equation involving partial derivatives with respect to more than one independent variable, which is called as partial differential equation. So in this case, the definitions say about the equation number 5 or 6, both are in equation number 5 and 6. So these are the term type. So of taking a derivative type. So here is the some derivative delta 2 delta 2p upon delta ts, which is equal to k delta q upon delta a whole square. Okay. And similarly in part C also you see here the derivative partially derivative type portion, delta portion. So these are the both partial differential equation. Understand? A differential equation involving, understand, I am say you second time, keep in your mind. So a differential equation, which is called as. Now come to the next part, which is our order of differential equation. So you the order. Okay. Next one is our degree of differential equation. So the order of highest derivative. First, what keep in your mind, the order of highest order derivative involved in differential equation is called the order of differential equation. It means the order of the highest order derivative. Okay, involved in a differential equation. So how can you check that order and degree of the any differential equation? I will give you some example here. Take y double dash plus log xy which is equal to 0. Find this their order. Okay. The main concept I will revise something like order and degree not, but I move on the degree part. Okay. Here I am show you the degree of differential equation. The degree of differential equation is the degree of highest derivative which occurs in it. After differential equation, some free radicals are formed, like a fraction or as a derivative are considered. So here is some example: y dy upon dx. Let's change the pen color. Okay, which is equal to under root x dy upon dx whole square plus k. So what the definition tells you, find their degree. Okay. So first you maybe change the check the definition what the degree of say that the degree say that you the degree of highest derivative which occurs in it. So check their higher derivative. Higher derivative only look like this x square type. So here dy upon dx y double dash. So what the degree? It is a form of second degree. Okay. So equation number first 2 and 6 are of first degree, and making equation 3 free from fraction, then you can check this. Okay, these are the equation number 3 I think. Then move on, these are the type of second degree. Again, much square both side of 4 to make it free from radical, and my definition of the degree of 4 and 5 is 2. How can you judge this? The degree of 4 and 5 is to check their highest derivative portion. Okay, so degree of 4 and 5. So equation number 4 is what? Equation number 4 is look like this. This is the equation number 4, and this is equation number 5. When you simplified this, you maybe change in the simplest form, and you will get something like the degree. Check their highest derivative part. Okay. Now move on next concept, that is linear and non-linear differential equation. So what is linear and non-linear differential equation? Firstly, in case of linear um, differential equation, linear term कब होगा? Linear term. Here and here is non-linear. When you say that the term is the differential equation is linear, first every dependent variable and every derivatives involved occur in first degree. Okay, what? Every dependent variable and every derivative involved in the first degree only. And second thing, first what? First is every dependent variable and every derivative involved occur in first degree only. And second things is differential extent a differential equation which is not linear. First thing keep in your mind two terms. First one is every dependent variable. Dependent variable which means what? Y is equal to fx, and must be know here is the dependent, here is independent part. So every dependent variable and every derivative involved may be changed into double derivative. It means d2y upon dx square. Okay. So involve occur in first degree only. So this is the part of first degree only. So you say that it is a part of linear type. But second things is that no product of dependent variable and or a derivative occur. Okay. So a differential equation which is not linear, it is not linear, then you say that this is a part of nonlinear, uh, nonlinear differential equation. So I have example 1 and 6 are so come to 6 linear differential equation part. So I will move on number first and then erase all. Okay. So check here. I will give you some how to change the linear property type and maybe the equation number first is say you it is a type of linear and in a sixth part it is also a type of linear. Okay. And the rest are 2, 3, 4, 5 are non-linear. It may be changed like this. So wait a minute. 2, 3, 4, 5 are all are non-linear. First things is that for when you move on check portion, then firstly you keep in your mind every dependent and every derivative involved occur in first degree. So let's move on the example portion. Here the derivative are in a first degree type. When you simplified this or maybe written like in a standard format, then you see this equation look like this now. Dy upon dx which is equal to x plus sin x type. Okay. So maybe it is a type of first degree type now. So maybe it is a type of linear. So here what is this? Here is also say that this is also a part of linear type. So how it may be possible? So delta 2u upon del x square plus delta 2u upon del y square plus delta 2u upon del z square which is equal to 0. But here second thing is that the higher derivative and the definition say you this is are the same. I think they are no product are all are same. To move on the linear and non-linear concept. First things is that the independent variable every derivatives involved occur in first degree only. The derivative are in a first degree or not? Maybe. I hope you understand this. And second thing is that no product of dependent variable and or a derivative occur. Maybe no product of variable. Okay. And or a derivative occur. So before the conclusion is that when you look like here, their power are only their degree as same, their order are look like a higher derivative are same, but their degree are only one. Yes, because the definition say you order and degree. Order say you the order of highest derivative, order derivative involving a differential equation, order of highest order derivative, and maybe it's look like a delta v upon delta x square types also look like this now. So and degree part, the degree of differential equation is what? The degree of differential equation is says that the degree of differential equation is the degree of highest derivative which occurs in it after differential equation. You keep in your okay. come to this solution. So choose some order in your mind. Okay. So now the equation number first and six are the type of linear type. Okay. These are the type of linear. Equation number first and six look like a linear type, and rest of R look like a non-linear type. Okay. So you understand this now. Now our next concept, that is family of curve. Family of curve is nothing but you may be some includes here as a circle part or a sphere part. Maybe I will give you some example like this now. I will give you some example like this. Take a one. Today I am learn one more the similar type of concepts. Okay. So first, I things I am tell you. If there is any space, okay, take there is any open space, and then take one point and uh, cut their slices and move on the this type of concepts like find the Lagrange method or find the Sharpe method, that is linear part or not linear part. Okay. So maybe the concepts like this you have already studied in your basic classes, but I am telling you something new which is related to differential equation, because differential equation is nothing but it is a real type problem solution are given also here. So maybe you have some equation comes like this. Now I will give you some more touch about what I'm trying to say you. I'm trying to say you I am trying to say you something Lagrange method type. When we move on Lagrange method, then we study something like this. So the family of curve is nothing but it is a set of relation of the formation in 2D plane, okay, or n plane. Okay. So I am say you the parameter one parameter family if C is or are non-negative or many things. Now I'm tell you something new about something new concepts related to this. Okay. Where I'm telling you here. Okay. So I will give you some P X Y Z. Okay. These are type of ZX. Maybe it comes next class, that is because in case of linear we study a Lagrange method, okay, to solve any problem, or in case of non-linear we study a Charpit method. So the concept related to this, okay, this is a type. Okay. So that method anyway, there must be algorithm relation between C1 C2 some integral surface or anywhere you can apply this. So here Pxy it goes in your out of I am think my Wi-Fi is not working. Maybe some issues are coming here because some problem I face. Wait a minute. Streams are live. Okay, I think the issue is solved. Now move on the next part. What I'm trying to say you. So everything is fine or not? Because I see also in my camera, also in my mobile. Okay. So first thing, okay. So Lagrange method is what it means. Take here p x y z terms type and q x y z z y which is equal to r x y z. First thing is that what about their general solution? What about their characteristics equation? And what about their steps to solve this type of problem? Okay. So firstly, I am move on the next part, which is our general solution. There are three type of solution. Na? One is general solution. Second is integral type solution, and last one singular solution. So I'm next one. I move on the part, but I'm going to teach you something related to this problem are coming in a family of curve type. Okay. Okay. So nothing but it is a n parameter family of curves. Okay. It's just set of relation of the form of x, y. Which type of relation? Relation is look like this now. Relation is look like this. X, Y, take here some circle and one more circle and one more circle. Okay. These are the type of family of curve type. Family of circle or family of curve type. But one thing is that here you maybe say at X, Y. Okay. X, Y is mapping with F, X, Y, C1, C2 goes up to Cn, which is equal to 0. So where f is real valued function and the function look like this x, y, c1, c2 and up to cn. And each ci where I is implemented as 1 to up to n range over an interval of real values. For any example, the set of constrict circle defined as x square plus y square is equal to c. This is the one thing is that it is a equation of what? Equation of circle is one parameter family of C takes all non-real values and again the set of circle defined by x minus c1 k square plus y minus c2 k square which is equal to c. 3 is a three parameter family if and c2 all are c3 takes all non-negative real values. So one thing is that here you maybe say that take a one example is x square plus y square that is the one parameter family. If C all non-negative real values, C takes all. I think visual in my hand. Okay. So here one thing is that plus y square is equal to C. The figure is not necessary. I am going to remove this. Okay. Okay. Yeah. Take here the one example as the formation of so take here as a standard equation of x square y square is equal to c. that is one parameter family if C takes all negative real values. Okay. And again, the set of circle defined by is this type of family. This look like a three parameter family type. Okay, because here is the written here the for say two. These are also non-negative real values. So family of curve if C1, C2 take all real values and C3 takes all non-negative real values. Okay, so I think you understand this now. I will move on next part. Move on. Complete primitive or general solution, that is particular solution and singular solution. There are three type of solution now. So first thing is for general solution, second solution for particular solution, and lastly the singular solution. So how you can say that the given solution is general solution, particular solution, or singular solution? Okay, I think you understand the point. First thing, I will highlight this term general solution, particular solution, and singular solution. I think this may be clear to you. Okay, so let the something equation like this fxy y1 y2 up to yn, and y1 is nothing but it's look like a y dash y double dash or up to y and dash. Okay, so maybe the nth order ordinary differential equation, maybe it is a type of nth order ordinary differential equation. Okay, so you study here the general solution, particular solution, and singular solution. So how you say that the solution is given here is a general solution? Okay, a solution of first containing an independent arbitrary constant is called as a general solution. And next thing is that what about particular solution? The solution of first obtained from general solution. The solution is first form obtained from general solution. Okay, by giving a particular value to one or more and independent arbitrary constant, which is called as particular solution. And next one is thing the solution which cannot a general solution, not a particular solution. And then you say that the solution is single. How think I will teach you addition for you a more definition about particular solution and singular solution. So now we'll go to write this. Okay, I think I am you write in your call. Okay, I'm definition about general solution. Write a solution of the differential equation is number of arbitrary constants. I repeat again, a solution of the in which number of arbitrary constant is equal to the order of the differential equation is called general solution. Again, I am repeat general solution. A solution of the differential equation in which number of arbitrary constant is equal to the order of the differential equation is called general solution. I think you understand this now. Again, I am repeat this. Okay, general solution. Write in your copy. A solution of the differential equation, okay, in which number of arbitrary constant, okay, is equal to the order of the differential equation is called general solution. I think your work is done here for about the general solution. Now move on the second definition, which is our particular solution. Okay, so write in your copy the definition about particular solution. Okay, now the sound is perfect or yeah, it's fine here. So what about the particular solution? So particular solution is nothing but a solution of the differential equation obtained from general solution by taking some particular value of all arbitrary constant is called particular solution. Same thing is that written here, a solution obtained from a general solution of the given particular value to one or more of the n independent arbitrary constant is called as particular solution. Same things you can write, okay, for particular solution. Now move on the singular solution. So one point are written here, one things written here, a particular solution. Here you write there are always infinite particular solution. There are always infinite particular. Okay, write in your. Now move on the next part. We have singular solution. A singular solution, a solution of the differential equation, which is neither or general solution nor a particular solution, which is called as singular solution. The student can easily verify this. So the rest class today going to this class, and next I will teach you something new about formation of differential equation. So firstly you read this and then I will teach you this. Okay. So thanks for watching these videos. Now the time is close the class today. Okay. Please like, share, and subscribe this. The class is for you. It is helpful or not? Please say me in the comment box. Okay. And my image is I and my photo is not clear. Look like this. Okay. So the definition of differential